So if we can lift humanity on a higher growth trajectory in the long term by improving science, by making it more accessible, more robust, more efficient, by doing more of the right things, then we can literally solve a lot of the problems that humanity has. I'm Philipp Koellinger, and we started DeSci Labs and the DeSci Foundation. DeSci, or decentralized science, is the attempt to improve science with Web3 based technologies, improving the way how science is being published, improving the way how science is being evaluated and curated, improving the way how science is actually being done in the laboratory or in the way that you're analyzing data. And it could also mean improving the way how science is being financed and how scientific impact is being evaluated. We're basically developing technologies to improve science. So I'm a scientist myself, so this is something that I'm obviously very, very passionate about. And from my perspective, at least, science is sort of the greatest achievement of humanity. It's our way how we differentiate between right and wrong explanations about the world. It's the source of technological progress and economic growth. But there are a lot of structural, fundamental problems in science that every scientist is familiar with that we're trying to tackle with the technologies that we're developing. There's a growing recognition in the scientific establishment, among scientists, among institutions, that things are ripe for a change and that Web3 technologies have the potential to really disrupt things. We keep reinventing the wheel over and over and over again. Making data fair is a way out of that. Fair stands for findable, accessible, interoperable, and reusable. These sound like extremely basic conditions, but in the vast majority of cases, scientific data doesn't fulfill these requirements, or even one of them. A lot of scientific data that people could in principle, or that scientists could in principle use to make progress, is just not accessible. That means that we're wasting resources to actually collect data over and over again. It also means that we have very limited abilities to actually reproduce and check findings that people have reported upon. There's a grassroots movement which has been going on for several years where a lot of people have been raising awareness that fair data is an important part of science. And they've reached support from funding institutions and from governments. And there's a lot of little island solutions and things that people have played around with, but none of it seems to realize the tremendous opportunities that Web3 offers for that. It just completely blew my mind that in this community that is so aware of the problems that we have and that we need to solve, there seems to be a complete lack of an understanding that there is already a technology out there that can actually solve that, right? So with IPFS and with content-address storage, we actually have a superpower that we can bring to the scientific community and that can be the basis of solving a lot of these problems. DeSci Nodes are a way for researchers to publish their research. It's a completely new way of sharing scientific knowledge with the world because it's not only based on PDFs, what the current scientific publishing system is based on, but it's based on actual research objects. So what's a research object? It is the manuscript, but it's also the code, it's the data, and it's all of these things interconnected and being interoperable. This research object basically becomes a living thing that tracks the entire life cycle of the research project. All of that is going to live in the open. No paywalls, everybody can access it, everybody can read it, and everybody can interact with it. So I trained in economics, and then after my PhD, I went to Holland, became a professor there, so went through the ranks. Then sort of mid-career, I got really, really interested in genetics. There is sort of an irony to it, because at the beginning of my career, as an economist, I was actually studying entrepreneurship and innovation. So I was literally looking at these weird little creatures that are starting companies, and the vast majority of them, of course, fail. And this, from an economic perspective, this is an interesting puzzle. Why do people do that? Although the statistics clearly clearly say that on average, this is a really bad idea. You have to be overconfident. You have to be extremely optimistic to get the energy and the conviction to do that. It's a necessary evil in a way. The advice as an economist is don't do it, but the advice as a founder is definitely do it. And what I found along the way so far is that it's incredibly helpful to have the right partners and strong partners to keep your eyes open for that. So we're really new to the Protocol Labs network. I knew that by the time that that we would join, that this would be the right choice, and that Protocol Labs is going to be great partners. But I had absolutely no appreciation just for how many resources the network has, and like this entire idea of this Protocol Labs network of all these different parties and projects that are doing independent things, and that have this ability to constantly innovate and to support each other, and like this modular nature where everything sort of like fits together. It's so incredibly powerful, and it's really amazing for us to be part of such a strong team, such a strong network where so much creativity, so much resources live, where we can literally just grow with it. This is the reason why I left academia. I think I already thought of myself as somebody who makes a dent in the universe with the research that I'm doing and the discoveries that we made, and like by changing the way how people are thinking about certain things. But I now think that a much bigger impact is going to be building this and making it a success. So if we can actually improve science even just marginally with the stuff that we do, I think the downstream consequences for everybody are just going to be huge.